Have you ever gazed up at the night sky and wondered how our solar system came to be? Our journey begins a staggering 13.8 billion years ago, with the event that sparked the creation of everything we know, the Big Bang. Picture an infinite expanse of nothingness suddenly erupting into a fiery maelstrom of energy and matter. This was the birth of our universe, a cosmic explosion of unimaginable scale and power. In the aftermath of this cosmic cataclysm, the universe was a swirling, chaotic soup of particles. From this primordial stew, the seeds of galaxies, stars, and planets were sown. Amidst the turbulence, tiny particles began to cling together, drawn by the invisible hands of gravity. These minute clusters, over billions of years, grew into the cosmic bodies that populate the universe today. Imagine an immense cosmic dance, with particles swirling and spiraling, gradually forming galaxies. In these galaxies, massive clouds of dust and gas, known as nebulae, began to contract under their own gravitational pull. As these nebulae condensed, they spun faster and faster, flattening into spinning disks. Within these disks, at the very heart of the nebulae, the pull of gravity was so strong that it ignited the birth of stars. These stars, in turn, gave birth to planetary systems, including our own solar system. The same gravitational forces that sparked the creation of stars also caused particles in the surrounding disk to collide and coalesce, gradually forming planets, moons, and asteroids. This was a time of chaos and creation, a time when the universe was taking its first steps towards the complex structure we see today. The building blocks of the universe had been formed, and the stage was set for an even more fascinating chapter of cosmic evolution. As we delve deeper into the story of our solar system, remember that it all began in the aftermath of the Big Bang, in a universe filled with possibilities, where gravity molded the basic elements into the celestial bodies we see today. The stage was set for the birth of our sun and the solar system as we know it. The heart of our solar system, the sun, wasn't always the bright beacon it is today. Before the sun was born, there was a vast, cold expanse of space, punctuated by clouds of gas and dust, known as nebulae. These nebulae are the cosmic nurseries where stars are born, and our sun was no exception. Imagine a dense, swirling mass of hydrogen, helium, and a smattering of other elements, all gravitating towards a central point. In this nebula, something remarkable started happening. The particles began to clump together, their combined gravity pulling in more and more material. The center of this accumulation became denser and denser, the pressure and temperatures rising steadily. This was the beginning of a process known as gravitational collapse, an integral part of star formation. With the increasing pressure, the core of this proto-sun started to heat up, reaching temperatures of several million degrees. This heat didn't come from the nuclear fusion that powers the sun today, but rather from the conversion of gravitational potential energy into thermal energy. It was a bit like a cosmic pressure cooker, with the ingredients slowly coming together to create something new and powerful. After a few million years, the core had become so hot and dense that hydrogen atoms began to fuse together, creating helium. This process, known as nuclear fusion, marked the birth of our sun. With each fusion reaction, a tiny amount of matter was converted into energy in accordance with Einstein's famous equation, E=mc². This energy flooded out from the sun's core, making its way to the surface and then out into space, bathing the surrounding nebula in light and heat. And so, from a cloud of gas and dust, our sun was born, a bright shining star in the vastness of space. Its light and heat would go on to shape the rest of the solar system, influencing the formation of planets, asteroids, and comets. With the birth of the sun, the foundation of our solar system was laid. Our sun was not alone for long. Around it, the planets were taking shape. In the wake of the sun's birth, a vast amount of material remained, swirling around in its gravitational pull. This leftover matter, a mix of gas and dust, began to form a flat disk around the sun, like a cosmic pancake. This disk is known as the protoplanetary disk, the birthplace of planets. Each particle within this disk was drawn to the others, a result of gravity's relentless tug. They began to collide, sometimes gently nudging, other times crashing violently. But, regardless of the nature of these encounters, something extraordinary was happening. These particles were beginning to stick together, forming larger and larger clumps. This process, known as accretion, was the first step in the formation of planets. These clumps grew over time, from pebble-sized pieces to mountain-sized masses, and eventually to planet-sized bodies, known as planetesimals. These planetesimals, each with their own gravitational pull, began to attract even more material, growing larger and larger. The larger they became, the stronger their gravity, and the more material they could attract. It was a cosmic snowball effect. However, in this chaotic disk, collisions were not always constructive. Sometimes these planetesimals collided with such force that they shattered into pieces. But even in destruction, there was creation. The debris from these collisions would once again join the disk, ready to start the process anew. Over the course of millions of years, through countless collisions and accretions, the planets began to take shape, each one unique, each one a testament to the chaotic yet beautiful process of planetary formation. The solar system was taking shape, but it was not yet complete. Even after the planets formed, the solar system was a chaotic place. It's hard to imagine, isn't it? But it's crucial to understand that our tranquil-looking celestial neighborhood was once a riotous, roaring arena of cosmic collisions. Welcome to the era known as the Late Heavy Bombardment. This was a period that spanned from around 4 billion to about 3.8 billion years ago. It was a time when the surfaces of the planets were shaped and scarred by an intense asteroid activity. This frenzied ballet of celestial bodies didn't just remodel the landscapes of the planets, it fundamentally altered their very compositions. Now picture this, a massive, Mars-sized body hurtling towards the young Earth at unimaginable speeds. A cataclysmic impact that was so powerful, it literally shook the world. This colossal collision ejected a huge amount of debris into space. This debris, over time, coalesced under the force of gravity to form what we now lovingly gaze up at in the night sky, our moon. But Earth wasn't the only planet that got a cosmic makeover. The rocky surfaces of Mercury, Venus, and Mars bear the scars of this tumultuous time. Even the icy moons of the outer planets weren't spared. The craters and basins we observe today are like a historical record etched in stone, chronicling the events of this ancient era. The Late Heavy Bombardment was a time of upheaval, but it was also a time of creation. It's believed that these asteroid impacts could have delivered water and other essential elements to Earth, setting the stage for the development of life. So next time you look up at the moonlit sky or marvel at images of other planets, remember the chaotic dance of asteroids that shaped these celestial bodies. The Late Heavy Bombardment left lasting marks on the planets, including our own. It's a testament to the dynamic, ever-changing nature of our universe. From the birth of the sun to the formation of the planets, our solar system has come a long way. As we traverse through the cosmic journey of our solar system, we're reminded of the extraordinary transformation that has taken place over billions of years. The sun, our star, once a mere cloud of dust and gas, now burns brightly, its fiery heart providing the energy that sustains life on Earth. The planets too have their own tales to tell. Take Mercury, for instance, the smallest planet in our solar system, yet it bears the brunt of the sun's heat, enduring temperatures that could melt lead. Then there's Venus, our closest neighbor, shrouded in a thick, toxic atmosphere that hides its surface from view. Mars, the red planet, is a testament to the possibility of life beyond Earth. Its dry riverbeds and polar ice caps providing tantalizing hints of a watery past. The gas giants Jupiter and Saturn dominate our solar system with their immense size and powerful magnetic fields. Uranus and Neptune, the ice giants, reveal the frigid outer reaches of our solar system. Their blue hues are a result of atmospheric methane. And let's not forget the dwarf planet Pluto, once the 9th planet in our solar system, now reclassified but no less significant. Our home planet Earth is a beacon of life, a blue marble in the vast expanse of space. It's a stark reminder of our unique place in the universe, a place of water and life, of green forests and blue oceans, of humans and other countless species. As we look out into the cosmos, we're reminded of our humble beginnings. We come from stardust, from the remnants of stars long gone. We're part of a larger cosmic story, a story of creation and transformation, a story that continues to unfold. Our solar system, born from a cloud of dust and gas, is a testament to the incredible power of natural forces and the wonder of the universe.